Hello, ladies and gentlemen. Today we're going to be taking a look at equations of circles. So this is a little bit of a tie to algebra, and for this you're going to need something to write with, a calculator, as well as your notes to jot down some of these key ideas. So like I said, a little bit of a tie to algebra, so let's just visit where we've been. General equations that you've learned from algebra, general equations. So if we were going to graph a line, we might use our number one line formula here, y equals mx plus b. So remember, once you understand what the m and the b represent, sketching it's pretty simple. Like in this one, the b is 4, that's the y-intercept, and the slope is 1/4, or up 1 over 4. And that's where you see this graph here. The same thing in Algebra 1 happened when we had parabolas. So we'd learn what the a, the b, and the c represent in the equation, and we could sketch a quick graph of the parabola. Well, the same thing's going to happen here as we continue our study of circles. So this is the circle general equation. You need to get this part down in your notes. The circle has a center at what's called hk and a radius of r, and it's written like this. So we have x minus h, remember that's part of the center, squared, plus the quantity y minus k, again that's the y part of the center, squared, and then that equals the r, or the radius, squared. So notice again that the h and the k are the points or the coordinates from the point that represents the center, and then you put x minus or y minus, depending on if it's the y part or the x part of the point. And that r again is the radius squared. So let's take a look at how this would help us. If we had to write an equation of a circle with a center at 0, -9, and a radius of 4.2, what would that equation need to look like? Well, we would first start with the general form. X minus h squared plus y minus k squared equals r squared. And now remember, this center, these two numbers or these coordinates represent h and k. So we'll just plug those in. So it would look like x minus the h, which is 0, squared, plus y minus the k, which is -9, squared, equals the radius squared. Now in this case, the radius, 4.2, so 4.2 squared. Now if we went ahead and simplified this, guys, what's x minus 0? That would be 0, so this would be x squared plus, now inside here I see I have a minus or subtract a negative, so I would simplify that as saying y plus 9 squared. And then we would go ahead and actually calculate that 4.2 squared. 4.2 times 4.2, and that value becomes 17.64. So this is the general form of an equation, okay, or a circle that fits that description, that has a center where we wanted it and a radius of that we wanted. So we would do the same thing on this next one. Write the equation of a circle with a center at 0, 0 and a radius of 7. So we would start again with the general form, x minus h squared plus y minus k squared equals r squared, and then we'll go ahead and plug in what we know. The h and the k are the coordinates from the center, so it would look like x minus 0, because that's the h, and then y minus 0, because that's the k, and then the radius was 7 in this case, so we'll plug that in. And again, if we simplify, x minus 0 is 0, so this is, or x minus 0 is x, sorry, that is x squared. Y minus 0 is still y, that's y squared, and then 7 squared is 49. So we can write these general equations using that general form and just plugging in what we need. Well, what if we have a picture like this? The point -5, 6 is on the circle that has a center at -1, 3. Write the equation of this circle. Well, if I can see the circle, I can do this. So remember, we're talking about that general form equals the radius squared, so we'll call it r squared. And now if I look at what I need, remember h and k are the center. So the center is here in this circle or here in this list of points. So we'll go ahead and plug in. It would be x minus the h value is -1 plus y minus the k value is 3. And now I'm ready to plug in that radius. Well, what would the radius of this circle be? Well, in this case, I can actually see the center, and I can go out and count those boxes to find that radius. So 1, 2, 3, 4, 5. That is 5 for my radius, so I plug in 5 squared. Okay, and then we'll simplify. X subtracted negative 1 is like x plus 1 squared. And then this stays y minus 3 squared equals 25. So we can see that the h and the k are plugged in there, the radius is plugged in there, because we've written the general form of the equation of the circle. Well, what if we don't have a picture, guys? What would we do? If I have a point that's on the circle, and its center is at 2, 6, we need to still write the standard form for the equation of the circle. Well, let's start with that standard form. Y minus k squared equals r squared. Hopefully you've written it enough where you can start to remember it, okay? Here's what we have. X minus, who's the h part of the center? Remember that you're looking at the center here, h and k. So h is 2, so we'll plug that in. And then we'd have y minus, what's the k value for the center here? That's 6 squared equals r squared. So we've plugged in the center. Do we have a radius here? And we don't. It doesn't say anything in here about a radius. And because I don't have a picture, I can't physically count the radius. And I don't really want to take the time to draw a picture if I don't have to. That means you have to have graph paper and have to draw it accurately and be careful to use a compass and all of those things. So how else could we figure this out? Well, if you don't have a radius, we can use this to solve for radius as well. Remember this other point that we didn't use? That's just a random point. This other one with the h and the k, we use this. This was the center. We already plugged that in. But the other point over there has an x and a y. And if that x and y are on the circle, we should just be able to plug them into this general form to help us solve for the radius. So what would that look like here? Well, I take my minus 2, but where that x is, I'd plug in the x value from this point, which is negative 1. Okay, and then when I keep copying here, when I get to the y stuff here, my minus 6 will stay, but now I want the y value from the point. That's a 2. And then I'm still going to leave that equals r squared there. And now if we simplify that side, we can now help ourselves solve for the radius, or solve for r. So what is negative 1 minus 2? That's negative 3. So this is negative 3 squared. What's 2 minus 6? That's negative 4. So that's negative 4 squared. And that's going to equal r squared. Now what is negative 3 squared? That's 9. And negative 4 squared is 16. Remember, anytime you square a negative value, it's still positive, okay? It becomes positive. Negative times a negative. So what we have here is 9 plus 16, which is 25. 25 equals r squared. So what does that mean for the radius? Well, it means the radius is 5 if you square root. So now we know what that radius is. Now we can go back to where we were kind of stuck right here when we didn't know a radius. To write the general form then, we'd say it's x minus 2 squared plus y minus 6 squared. And now we've actually solved for that radius, and we'll say 5 squared for the radius, or x minus 2 squared plus y minus 6 squared equals 25. So this guy right here is the general form of a circle who would have a center at 2, 6, but also pass through this point, creating a radius of 5. So we solved for that radius using the general equation of a circle, just like you might solve for the b using a general equation of a line. It's that same idea. And you'll continue to use this idea into Algebra 2 as well, as you plug in general points to solve for things you don't know about parabolas, absolute values, and so on. So this is the big idea we need to focus on. Make sure that you can get these circles under control. One more example and then we're done. Graphing circles, what if you had to actually make a picture given a general equation like this? Now remember, this is the equation. This is the general form right underneath of it. So can we pick out, let's say, what the radius was? Well, we know the radius is squared at the end. So what number squared makes 36? I know my radius has to be 6 then, because 6 squared makes 36. Where's my center? Where's my H and my K, my center that I can use to sketch my circle on this graph? Well, notice that it starts with x, subtract sign, then the h. So x, subtract sign, this is the h. So the h is 4. And then it goes y, subtract sign, k. But notice that I've changed that to a y plus 2 in my equation. That means that the y part of that point must have been a negative 2, because that's the only way you'd get a plus there. You'd subtract a negative 2. So now I know where my h and k are, and I know what my radius is. I can go over to my graph and plot. I'll start with the center. So start at the center. 4, negative 2, this represents the center of my circle. I'll put a C there. And then we need to have a radius of 6. So you're just doing a rough sketch here without a compass, but we need to count out 6 boxes up, down, left, and right from here. So if I go 6 to the right, I'd end up over here at 10. If I go 6 to the left, I'd end up right here. If I go 6 up, I'd end up right here. And if I go 6 boxes down, I'd end up right here. Oops, at negative 8. So we need to now draw a circle as best we can, of course, because it's a rough sketch, through these points to try to draw that circle that has that center, okay? That's the big idea. We're looking for, can you pick out a radius? Can you get that center? Can you work with those equations of circles? I want to thank you for taking good notes, and I'll see you later.